All right. It is recording. So does everybody see this screen? Like with the notes?
Yeah.
Area of a sector? Yes.
Yes, cool. All right, because we left off talking about this activity on Friday, and then this led to, so we just talked about looking at the area formula, and so what Archimedes essentially did was creating this formula. If we just created all of these n-sided polygons over and over and over again, as n goes to infinity, we end up pretty much rounding out that polygon to where it becomes this formula, pi r squared, which was kind of cool. Very complicated. It has some calculus involved in that, but we don't have to do that. We just essentially need to know this. So.
We just need to know pi r squared?
Yeah, that's the area of a circle.
Okay. So I don't need to find the little piece at the end of that pizza crust?
No.
Okay, great. I was really nervous about that.
And so, and then this, when you're only talking about a portion of the circle, so I essentially am finding a percentage or a ratio of that circle. This is how we can just find the area of this little pie piece here. It's just taking the central angle measure, divide it by 360, because that'll essentially give you the percentage of that circle that you're talking about, and then you multiply it by the area of the entire circle, so you only take a percentage of that circle. Does that make sense?
Yes.
So like, for example, if I was talking about the circle here, and I made this angle 60 degrees. Yes, I know that's not drawn to scale, but, and I want to find this area of that piece here.
What's your radius?
So this would be, so this is 60, right? Let's make that a little darker. I shouldn't use the dark colored marker. Realize that now. So if I just take 60 out of 360, that's approximately how much percentage? About
0.17.
So that's approximately 16.7% of that circle, right? So if I take this number and multiply it by pi r squared, so if we say r is, somebody give me a number.
7.
7, okay. And we'll say centimeters. So that would mean that the area of just that piece would be 60 over 360 times pi times 7 squared. Which turns out to be 49.6 pi, which is approximately 25.66 centimeters squared. Is this going to be 16.7% of my whole circle? So if I just found the area of this whole circle,
No, I'm sorry. The people's faces are in my way. I gotta move them. Anyways, that is what just found the area of the circle, so now you gotta multiply it by 16.7%.
right, so if I found the whole circle, if I found out, is this 16.7% of that whole area? Because a lot of people forget about this part and they freak out about how to do this problem because they forget, they're just talking about a percentage of the circle.
Oh, yes.
I just noticed that over the last couple of years that I've taught this type of problem, that they tend to leave this question blank on tests because they just feel like they don't understand what it's asking, or they don't remember the formula, but when you're just talking about it in terms of percentage, I feel like it might help you remember where that formula came from. Does that make sense?
Yeah.
All right, so if we found the whole area, so that's going to be pi times 7 squared, which comes out to be approximately 49 times pi, 153.94-ish centimeters squared. Now it is 25.66, 16% of that number. So if I take this number multiplied by 16.7%, 0.167, and we get 25.707, so there's obviously rounding errors. So this number is 16.7% of 153.94. So you're just finding a percent or a portion of that circle based on that degree measure divided by 360. Does that make sense? Are we good?
Yep.
All right. Now comparing area is a similar figure. So we found out last time when we were talking about like the scalars of all that stuff last time, it was based on a ratio. But in this case, when we're talking about the area part, if we look at comparing that ratio of the areas, and so if I took the area of this big triangle that has base B, height H, so its area would be base times height divided by 2, right? Well, this guy is going to be a similar triangle, but they're going to be a ratio of scalar K. So B divided by B1 will be giving me my K. So if we know B divided by B1 equals K, or H divided by H1 equals K, because we said that when they're similar, the ratio of those linear measurements would be K. So if I put these in over each other, so we got the big triangle over the small triangle, obviously the 1/2 would cancel. So then I would have B over B1 times H over H1, just from fraction stuff. Well, this is K and this is K. So the relationship is K squared instead of just K. And since it kind of makes sense, because linear measurement, the degrees of those units is 1. But in area, we have degrees of their units to be 2, right? Because we're talking about 2 dimensions. Does that make sense?
No.
Right?
I mean, it kind of makes sense that it's square, but I also don't get part of it.
You know
Can say
what?
it one more time really fast?
Did I talk too fast? Is that what you said?
No, say it one more time really fast.
So when we're talking about linear measurements, the degree of the unit is 1, right?
Right.
And when we're talking about area, the degrees of the unit is 2, because we're talking about 2 dimensions, right?
Yes.
So when I'm talking about the ratios of the linear measurements, we have degree 1, right? These degrees in the power 1. We just don't ever write that exponent there, right?
Yes.
But now we're talking about area, which has degree 2. So the scalar has a degree 2.
Okay, that makes sense.
Does that make sense?
Yes.
Cool. All right. So we have this area for similar triangles with the scale factor of K. The ratios of the area is K squared. For any similar polygon with the scale factor of K, the ratios of their areas is K squared. So with this is a thinking question. Is it true that the viewing area of a 35-inch flat screen is about twice the viewing area of a 25-inch screen? And so we're talking about TVs being measured by their diagonals, right? That's how they measure TVs now.
Okay.
So if we were to think about this, would that be true?
I have to get out of this.
So we got this TV. And that's diagonal 25. And then we have a little bit bigger one. These obviously are not drawn to scale. And 35.
So if you drew them the scale, it would be not.
So based on this, since their scale factors are k squared, we could say 35 squared is to 25 squared. So what is that number? Thirty 35 squared is 1225. And what is 25 squared?
625.
625. So if I divide each of these numbers by 625, that becomes a 1. And what's 1225 divided by 625? 1.96. Is that about 2?
Where did the 1 come from?
Oh,
Yes, it is about 2.
Sophie, you gotta fix your microphone, dude.
yeah, it's very
I can't hear
echoey.
anything Joni's saying.
That's because I'm right by Emily.
Oh gosh, is there a way to fix it? I can't hear Joni. Like I can't hear Joni at all when it I don't know when it echoes.
I'll just go into her room. You can set up too.
Yeah, your microphone is very, very sensitive. So this was turning this guy into a unit rate, essentially. So if I divide the top and the bottom by 625,
That's better.
did you fix it?
Well, I'm not by Emily anymore.
Yeah, it sounds better.
Okay.
Oh, y'all are sitting next to each other?
Yes, we want to do it just like math class.
Ah, okay. Now that makes sense because you were picking up probably her stuff too. That's what it is. Okay, cool. All right, so is this number 191.96 about 2?
Yeah. Yes.
Yeah. So that would mean that this area is almost twice the size of that viewing area. So I didn't need to buy a 50-inch TV to get twice the size. I only needed to buy a 35-inch screen TV to double my viewing area. Does that make sense?
Yeah.
Yes.
Cool. So that's what is demonstrating that relationship a little bit more. All right, so converting units of area. So we can't just, when we're looking at converting units, we can't just convert the final thing. We have a little bit extra work when we convert units of area. So these questions will come up. So if the price of a carpeted house is quoted in terms of dollars per square yard, for example, $2.50 per square yard. And so if we want to talk about converting between systems, we're going to have to worry about changing some things. So obviously in English, we talk about square inches, square feet, square yards, square miles. And then for land measurement, we have acres. And metrics, we have squared millimeters, squared centimeters, squared meters, squared kilometers. And for land measurements, they use the hectare. And so we would want to know how we would change from one system to the next, which was interesting because, like, if you're on Zillow and you're looking at square footage of houses, a lot of times the Canadian houses don't put square footage in their things, which is interesting. They just don't mention it.
Wait,
So.
they don't even put like square whatever they use.
Well, that's just it. They don't post it. And I'm assuming because Zillow's probably an American company and they don't do the conversions for them.
Oh.
So a lot of that's just what I noticed, that a lot of the Canadian houses don't post square footage because they don't use feet over there. They use meters. So some of them started posting it, but not all of them. I just noticed that when I was looking for houses when I was moving up here. And still now, I still look at those things, but yeah, just to see. But yeah, I just thought that was interesting. So let's look at that. Let's look at some of these examples here. Ooh, that's fuzzy. I need to move my window because y'all are blocking what I'm seeing. Over here. There we go. Oh, yay. Now I can see all of y'all. Okay. So we're looking at this thing. 1 square meter is actually 10,000 squared centimeters. So it's not just going to be move the decimal over 2 places. It's now moving it over 1, 2, 3, 4 places. Because
So
we're
it's like you
squaring
square
them.
how many decimals you move over.
Do what?
So normally you move it over 2 places, but now you have to move it over 4 places, which is 2 squared.
Right.
Just like that.
Just like that.
Oh, okay.
So if I'm changing, so you can do this in 2 steps. You can worry about doing the conversion by multiplying it by 10 to the 4th power for centimeters or meters to centimeters, or you can do the conversion by each unit individually. And this is how I like to do it, is that I convert each side individually to help me figure that out. So you can change this 1 meter to 100 centimeters and this meter to 100 centimeters. So that'd be 100 times 100, which is 10,000. Does that make sense?
Yes.
And then if I wanted to convert that to millimeters, well, 100 centimeters is 1,000 millimeters, and that's 1,000 millimeters, so that would be 1 million squared millimeters. And then same thing here. If I was convert that to kilometers, if I change a meter to a kilometer and 1 meter to what it is in kilometers, multiply that together, so that'd be 0.0000001 squared kilometers. So you would have to move it over 6 places, right? 1, 2, 3, 4, 5, 6. Not so, because like when you go from meters to kilometers, you move it to the left 3, but since we're squaring it, you now double that 3, so that makes it 6 places. Does that make sense? Cool.
Yes.
So see if y'all can do these 2 for me. Oh, nobody's charting me.
Joni, you want to know a secret?
Huh.
I can see you writing right now on your little screen.
Oh, you're not supposed to.
Well, I can.
Are you watching me in my little screen?
Well, I'm already done.
What's cheating?
Well, I'm just letting you know. I just noticed.
Did I do this right? Yeah. So did y'all get these answers?
That's exactly what I got.
Yep.
Very good? No,
I
not
got
you,
these.
Emily. Why not, Emily?
It's Kirby.
I have no idea. That's not.
I'll-
It's just not grasping, I guess.
I'll go look. I'll be right back.
So what I did here is I broke it apart. So I'm imagining this box, right? So this is a 5 and that's a 1. So I'm just going to convert this side. So this is going to be 50 millimeters. And that's going to be 10 millimeters. Make that look more like another M. So 10 times 50 is now 500. Same thing with this box. So if I make this one, this side 124, this side 1,000,000 meters. So if I make it kilometers, that makes it 1, 2, 3. 1, 2, 3. So now I'm taking 1.24 times 1,000 instead of that. And you didn't have to break it apart that way. This is just what I'm visualizing in my head because I need a picture to see what's going on. And you don't have to do it that way. You can use this conversion chart too. Those are equally the same. Does that make
I have
sense?
kind of a question that's not really related to this.
Okay.
What if you have a professor that still hasn't really put anything up yet for like
I would
classes?
still be a little patient. Did they send you any emails yet?
Just kind of like one, I think.
How many days ago was that?
I don't know. It's for arts methods. Does anybody remember? I was just wondering if like how
Oh,
long we
I
should
haven't-
wait
I haven't
for.
even- I didn't even see an email from her.
She sent out
Oh.
one email, and it basically just said that she doesn't know what we're doing yet, and that we're gonna have, like, she thinks we're gonna do Zoom, probably, but I don't know if she'll figure that out.
I just
I
didn't
didn't
know
even
if
see
like
that class.
Joni, I just didn't know if we were gonna get like in trouble or like penalized if we like missed a meeting or something. Like if we didn't see that she, I don't know, because she hasn't posted anything yet. I just didn't know if we were.
I feel like that's on her though. Like she should be letting us
yeah.
know what we're supposed to be doing, and she just hasn't said anything other than that one email.
Right.
Yeah. If
Most
that's
places,
all you
like
got,
everybody
I would
else has
just
something,
I would
so-
just wait. And
Okay.
you can't be penalized for that. Because like with my math methods class, like we're gonna meet today in person, but I will probably only do like 30-45 minute long meetings with them
Right.
and post videos for them to watch.
Okay.
And then
How
do,
are you
like,
gonna meet with
direct
them in
write-up.
person? I thought that was illegal.
You can't meet in
What?
more than 10, right?
What do you mean more than 10?
I thought you couldn't be like with more than 10 people on campus.
Right.
Go off campus.
We're not supposed to meet in large groups.
Right.
So I'm meeting with them online is what I mean.
Oh,
Yeah, through like what we're doing now, it'll be just like that. So we'll be doing some sort of like activities here, and then like, or we'll watch a video together online, and then discuss it.
makes sense.
Yeah. I'm trying to make it as much class-like as I can without it being boring. And like, because I think if I just like played videos for y'all and like recorded myself doing this stuff, it won't be the same.
Yeah, because I know what you're saying.
Yeah, and you won't be able to actually interject and ask questions. So,
You know how I feel about talking.
yeah, we're gonna do our best, and it says that we only have 5 minutes left, so maybe we can finish this. And then I will do Pythagorean theorem.
Are we gonna be starting another one, or are we just done in 5 minutes?
Oh, today's a long day, right?
Yeah.
I'm gonna see if we can just maybe if I end the meeting and then start a new one and see if everybody can just click the link again. And see if
Okay.
that works. And if not, sorry, we'll see you on Thursday. And if not, I'll set up a new link for y'all for next time.
Okay.
Thursday's long day too, right?
Yes.
Yes.
So we're not just doing 12 to 12:40 for all 4 days.
Do what?
We're not just doing 12 to 12:40 for all 4 days, because that's what it said in the email. So I didn't know if you were shortening that or not.
Well, like, and then sometimes, like this morning, I was able to talk for an hour to my other class. It didn't kick me off, but then it kicked me off in my other class.
So I'll just kind of see what it does today, and if it lets you, we'll still stick to like long days and then short days.
Yeah, we'll try.
Okay.
Try to keep it as close as possible, because technically you're paying to see me.
Yeah.
So
Yeah.
I don't want y'all to feel shorted. All right, and so this also works the same way as with yards. So obviously we have 1 yard, 1 yard squared. So 1 yard times 1 yard, change it to 3 feet times 3 feet, and that can make that 9 feet squared. So this would be a conversion chart that you could use. I personally like to go back to this, so that way you don't have to worry about rederiving these charts. I feel like that's overly complicated. As long as you have the linear conversion chart, you can do that. So. And then here's some of the metric units and acres. So 1 acre is equivalent to 40 square yards, and 1 square mile is 640 acres. And then 1 square kilometer is going to be 100 hectares.
Okay, I have a question.
Yes.
So let's say you were given 1 mile, and then you have to convert into inches. You see those numbers over there?
Yeah, they're really
So
big.
would you just do like the 23 million feet times 144 inches? Is that what you do?
So
If you had to convert 1 mile into inches?
inches, yeah. So I would convert this. So if you had the feet and then multiply that by 144. Yeah. that's-
Okay, just, yeah. Okay, sounds good.
Good.
Yes.
And then you have some homework problems for y'all to work on. Yay. All right, Pythagorean theorem. right. So before we dive into this, I'm gonna see if we can just stop this meeting and then start a new meeting. Does that make sense?
Yes.
So I will see y'all in a little bit. So I'm
Okay.
gonna stop recording and then end it. So. Where is my thingy?
I don't know.
They're supposed to be like, there we go. Stop recording.